Hello friends, this video on equilibrium part 24 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's talk about a new topic called ionic equilibrium. What is ionic equilibrium? Before we start ionic equilibrium, let's start with electrolytes. What are electrolytes? Electrolytes are nothing but substances which conduct electricity in their aqueous solution. As the name suggests, electrolytes, that means substance which conduct electricity in their aqueous solution. For example, I have some aqueous solution of NaCl and I put in water to make it aqueous, and you put the setup like this where you have a battery, you have a bulb, and then for bulb to glow, the electricity has to flow from here to here. That means this aqueous solution should conduct electricity. So if aqueous solution conduct electricity, that aqueous solution will be electrolyte. Correct? So substance which conduct electricity in their aqueous solution will be called electrolyte. So NaCl, if you take, it will conduct electricity. So there are different kinds of electrolyte. Some are strong electrolytes which ionized completely in the solution. For example, if you have 1 mole of NaCl and you'll put in water, it will almost all the mole NaCl will break into Na plus N-. That means whatever amount of NaCl you put in the water, everything will break into Na plus and N-. Almost 99% of them will break. The other electrolytes are weak electrolytes. They are weakly ionized. For example, if you put this CH3COH in water, you will get H3O plus ion and CH3O minus ion, but maybe 10%. In this case, maybe 99% will get ionized. In this case, maybe 10% of these will get ionized, the rest 90% will still be there. Right? So they are weak electrolytes. Strong electrolytes, weak electrolytes. Also, if you see the difference here, in case of strong electrolyte, there is only one side reaction because almost 99-100% is complete. But in case of weak electrolyte, if you see, there is something called equilibrium. And there is an equilibrium sign here. Because in case of weak electrolyte, only a small percentage of the electrolytes actually get ionized, and the reverse reaction also takes place. It reaches the equilibrium and then we can apply all the laws of equilibrium which we have learned. Right, and that's why our focus will be weak electrolytes where it partially gets ionized and there's an equilibrium here. So in case of strong electrolytes, strong acids also, if you see, it gets almost completely ionized. So it is not a reversible reaction, it is not an equilibrium reaction. But in case of weak electrolytes, it partially gets ionized and we have equilibrium there, and we use all the principles which we have learned. Right, so we'll be focusing more on weak electrolytes. And please note, only weak electrolytes are in equilibrium, as I told, because they have only a small fraction of the electrolytes get ionized. And please note, the electrolyte may be acid, base or salt. So we'll learn more about acid, base and salt. We already learned those things in our class 10, but we'll do a revision once again for acid, base and salt. So what are acids? Acids are sour in taste and they turn blue litmus to red. So blue litmus to red is the 100% guaranteed test for acid. And they liberate dihydrogen on reacting with metals. For example, HCl react with some metal, you will get hydrogen gas. There are various definitions of acid we should be learning in the next few slides, but generally acids, they are sour in taste and they convert blue litmus to red. There is a litmus paper you must have used in your lab, which if you are using blue ones, it will convert to red. Base, on the other hand, are bitter in taste and they turn red litmus to blue. So if you have red litmus paper, it will convert to blue. And a good example is the washing soda, which we use for washing purpose. Now when acid and base, they are mixed in the right proportion, they give something called salt. So you know acid, you know base, you get salt if you mixed acid and base in the proper proportion. Example, sodium chloride. Sodium chloride is nothing but you get HCl plus NaOH, you get NaCl plus water. So this was my acid, this was my base, I got salt. Similarly, barium sulfate, sodium nitrate. So you get salt when you mix acid and base in the right proportion. Now, having understood the definition of acid, let's understand what is strong and weak acid and strong and weak base. Because for us, we'll be more focusing on the weak base and weak acid, because this is the one where you get equilibrium and all the laws of equilibrium which we have learned is applicable. A strong acid and strong base, they ionize completely and the laws of equilibrium doesn't hold true, right? So strong acid is the one which that gets completely ionized or dissociated in water. For example, you have H2SO4, is a very strong acid. The moment you put in water, this becomes H plus and HSO4 minus ion. And almost 99 to 100% of this H2SO4 is ionized. So if you want to see graphically how it is, for example, there are four molecules. The moment you put in water, what happens is all these four molecules, they had this hydrogen attached, hydrogen plus attached, H plus is attached. But the moment you put in water, what happens is all these molecules break, and if you see almost 100% in this case, right? We had four molecules which had H plus ions attached, and all these four has liberated H plus now. Correct? This is, you can say, a weak, a very strong acid, because it had four molecules which had H plus attached. The moment I put in water, all these four molecules gave H plus ion. So very strong acid, almost 100% ionization. Weak acids, they only partially dissociate, and they exist at equilibrium, and at equilibrium acid and the conjugate base are present in the solution. We'll discuss more about conjugate base in the next few slides. So example, there is a weak acid and you have an equilibrium sign here, if you see. So it gives H plus and A minus ion, but there's a reversible reaction also happening. You want to see what happens, for example, in this case also I have a weak acid here which had four molecules now. Only four molecules I'm taking. The moment I put in water, what happens is, if you see, only two are dissolved. Here we see 50% ionization. In this case, two still has the two stills are in HA form, right? It's all HA, and two got dissociated, and two gave H plus ions. So in case of weak acid, the ionization or dissociation is not complete, maybe 30%, 40%, 50%, depending on the strength of the acid, right? But in case of strong acid, it's almost ionized. So the acid which ionizes more is strong, the acid which ionizes less is weak acid. Similar with the base, same thing. So a strong base is the one which dissociates completely in water. For example, NaOH is a very strong base. The moment you put in water, it becomes Na plus and OH minus ion. Very, very strong base, almost 100% ionization. But again, weak base is the one which is partially dissociated, and it exists in equilibrium. And here also we have both acid and the conjugate base. Here we have both base and conjugate acid. We'll discuss more about this thing when we talk about conjugate base and conjugate acid. So, for example, if you see ammonia is a very weak base, the moment you put in water, it becomes NH4 plus and OH minus. And here, if you see, it's an equilibrium, maybe 30% is ionized. I don't have data, but maybe a very, very small fraction of this is ionized. And that's why you have equilibrium sign. Please note, there is no equilibrium sign here, there is an equilibrium sign here, there is no equilibrium sign here, and there is an equilibrium sign here. So we discussed a lot about strong and weak acid. It's a good PPT where you have a list of strong acid and strong base. If you see hydrochloric, nitric acid, sulfuric acid, hydrobromic, hydroiodic, perichloric, these are all strong acid. If you talk about weak acid, we have acetic acid, formic acid, hydrofluoric acid, hydrocyanic acid, nitrous acid, hydrogen sulfate ion. These are all my weak acid. Talk about strong base, NOH, KOH, BaOH2, barium hydroxide, potassium hydroxide, sodium hydroxide. They are all strong base. We talk about weak base, ammonia, methylamine, pyridine, ammonium hydroxide. They are all weak base. Please remember these strong acid and strong base. If you want, you can note down these values in some paper and just learn these, because it's good to know what are strongest and strongest. When you solve questions with the acid and base itself, you can make out if it's strong or weak, and then you can take proper steps. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.